This is the 6th video in a series of 7. In the previous 5, I've been introducing you to a new geometric pattern that only exists on the base 12 Cartesian plane. So I've explained all that already. We have the dimensions of its shape, and now in this video we're going to divide the diameter of that geometric pattern into its circumference and take a look at the result that reveals to us the base 12 version of pi. So this is a big deal video. This is the number everybody's been waiting for. So we've already started that calculation. Let's just jump in to the square root of 4 do 2. And we've converted this length of 1.7 root 2 into a square root of 5.02. 1.7 squared is 2.61. Square root of that times 2 gives us the square root of 5.02. So we're going to do the equation of dividing the diameter of the dodecagon into its perimeter, and we're using this version. Of course, we can use any version of that combination because the proportions are always the same. So we're doing it in square root. So our answer is a square root, and it starts with the 9. Okay, so I'll just give you the first few numbers. 9.L8017191. Then it goes on 841567467 and on and on and on for 114 digits. That's in base 10. The last digit in that series is a 0, and then it repeats. So 114 in base 12, that's 9 do 6. Here we have 0.96. So the entire length of this equation, when we're dividing this into that, gives us a number with 9 do 6 digits. Okay, but it does repeat. So whether or not we want to call that pi, we still want to acknowledge that is a legitimate equation dividing that diameter or that length across this polygon into its perimeter. It goes on for that many digits and then it repeats. I don't know if there's any number like that we're familiar with in base 10. So for the longest time, I just thought that was a really interesting long number. But then I had the inspiration to write it out in lengths of 12. So again, we're in base 12, so why not? So I'm going to do that for you now and just show you what happens to this number, and we'll be able to look at it more closely. All right, so this is the number that you get when you divide the diameter into the perimeter of the dodecagon. Again, it's a square root. Starts out 9.L8017191.841. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 rows of 12 and a half. So there's that 9 do 6 right there. That's what it looks like. And when I wrote this out, I noticed something happening on this, in this row here. We got 1, 2, 2, 3, 3, 4, 5, 5, 6. So it seems like we've got sort of an odd progression of numbers starting at 1, going to 6, and it seems like we're halfway to somewhere. And so then I had the idea, well, why don't I just write that whole number out again, starting right here, and I'm just going to keep going. So that's what I'm going to do for you. All right, so now I've written out that same number again, second version, starting here, 9L8017191, and we look here, we ended at 6. That series continues, 77899 dec L00. So we end at 0. We started at 1. So if we go 1, 2, 3 columns over, here we go 1, 1, 2, 2, 3, 4, 4, 5, 6, 6, 7, 8, 8, 9, 9, dec LL0. 1, 2, 3, 3, 4, 5, 5. This series here is the same as this one here. This one here, 1, 1, 2, 2, 3, 1, 1, 2, 2, 3. What about those other columns? We start here. I'm going to count now. 1, 2, 3, 4, 5, 6, 7, 8. So you go 1, then 1, 1, 2, 3, 4, 5, 6, 7, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8, 3. So again, now we have every 8th numeral or number going through that, working through that pattern, emerges another version of this sequence from 1 to 0. But each sequence is a little bit different. Each one has different pairs of numbers. So basically there's 6 different patterns in here. So we have, again, 12 columns, and then 1 Do7 rows, or 12 rows and 1 Do7 columns. 1 Do7, 2 times 0.96, or 2 times 9 Do6, 1 Do7. So the question becomes, what do these patterns represent? We've got some kind of structure in here. We know pi is not only the circumference of the circle, but more importantly, it's the area inside. So what do these numbers represent? What do these patterns, what are these patterns of numbers emerging from? What structure is within the geometry of the area inside a circle or inside of a sphere? I think there's something here to explore more. So of course, again, I've gone over this in my book, and I show you this whole pattern of numbers. I show you the different patterns that emerge, the sequences of numbers. When you look in there, when you start to pull them out, there's 8, every 8th number, every 7th number, every 11th number in one of them, if I remember correctly. So I'll give you all that information in my book. Now I want to do another version of this long division equation. What we want to do is just cancel out those square roots and just do the sort of simple version of 5 divided by 1.7. What does that look like? So what is the sort of straight version of this square root? Similar to how 3 is the square root of 9. What's the square root version, or the, what's the reciprocal version of this square root number? All right, there you go. 3.1 dec 8 dec 1. Then we're back to a 5-0 again. So it repeats after 6 digits. 3.1 dec 8 dec 1. 3.1 dec 8 dec 1. 3.1 dec. Now I'm just going to do something now. I've gone halfway through the sequence. I'm just going to start again over here. 8 dec 1. 3.1 dec 8 dec 1. And what's interesting, again, I kind of got this idea from the other half there, this sort of overlapping half. Perhaps if we did this also for 9 Do 6 iterations, when you add these together, 8 and 3, 8, 9 dec L. Dec plus 1 is L. Dec plus 1 is L. 8 and 3 is L. So we get a number that's sort of equivalent to 9999999, but in base 12, it's L, 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 with a little gap at the end, or actually a little gap dispersed all the way through. So all those L's somehow, with space on the end, is going to make up a length of 1. All right, so that was number 6 in this series of most important math videos that you'll ever watch. And now we're going to go on to number 7, where we'll talk about the implications of this new Dozenal version of pi for physics. What does it mean, and where does it lead us now?